in the case of methane, heat energy is definitely given off. And so one way that we model it, because we want to know, okay, where does that heat energy come from? One way to model it is and you'll see this a lot, is they say, okay, well, the reason why heat is given off is because the energy of the reactants is greater than the energy of the products, okay? And because the energy of the reactants is greater than the products and energy is conserved, that energy is released in the form of heat. And in this case, this particular chemical reaction is 1 mole of methane reacting with oxygen to give carbon dioxide and water. And the heat that's given off is 802.3 kilojoules. And you notice that because they're stating here the energy difference, which is the change in energy, the energy difference, it's a negative number, and differences are always final minus initial. Since the initial was a bigger amount of energy, the difference is negative, and that is just by sign convention. Okay, and when we talk about this energy of the reactants, what is the energy? This is really the potential energy of the reactants and the potential energy of the products. And the potential energy has to do with the position of all these atoms in relationship to each other. The position of hydrogen and carbon and the 2 oxygens here is of higher potential energy than when they rearrange themselves. Remember, the matter is conserved. You still have a carbon and 1 carbon atom, but now they're surrounded by oxygen, and the hydrogen is with oxygen here instead of with carbon. And this particular arrangement of atoms is of lower potential energy than that, and that's why heat is given off across that chemical change. Okay, and then finally, the language that we use when we're describing this. Every time you have a chemical or a physical change, for that matter, there's an accompanying change in energy every single time. So every time we have a chemical change, there's going to be some kind of change, and the change is either going to be an endothermic or an exothermic. In an endothermic reaction, the energy of the products is going to be greater than the energy of the reactants. So in that case, you've gone from a lower energy to a higher energy situation, and so the energy change is positive, and energy would have had to have been absorbed by the system, and the system is the chemical reaction. An exothermic reaction, the energy of the products is less than the energy of the reactants, so the energy change is negative, as we just saw in the case of the methane.